And the handoff has occurred. Ground launch sequencer has handed off to Atlantis' onboard computers. 25 seconds.
Yes, sir. That's a minute. We're going to continue.
South compression water system is activated. 15 seconds and counting.
10 seconds.
T-minus 10, 9, 8, 7. Main engine start. 5, 4, 3, 2, 1. And liftoff of Space Shuttle Atlantis to assemble the framework for the science laboratories of tomorrow.
Houston now controlling.
Houston Atlantis, roll program.
Roger, roll Atlantis.
Atlantis' roll maneuver is complete. The orbiter's in a heads down position on course for a 51.6 degree, 137 by 36 statute mile orbit. All systems in good shape. Engines throttling down as Atlantis prepares to maneuver through the area of maximum dynamic pressure on the vehicle in the lower atmosphere. Already 7 miles away from the Kennedy Space Center at an altitude of 5 miles.
Houston, Atlantis, go at throttle up.
Copy, Houston, go at throttle up.
1 minute, 10 seconds into the flight, the 3 liquid-fueled engines are back at full throttle. At liftoff, the fully fueled shuttle boosters and external tank weighed 4.5 million pounds. It now has burned half that liftoff weight in propellant. One minute, 30 seconds. All hydraulic systems in good shape. The electricity producing fuel cells also in excellent shape as Atlantis heads downrange, 18 miles from the Kennedy Space Center at an altitude of 18 miles. The next event is burnout and separation of the twin solid rocket boosters, which are burning propellant at a rate of 11,000 pounds per second. SRB separation is confirmed 2 minutes, 15 seconds into the flight. Atlantis is traveling 3,000 miles per hour, downrange from the Kennedy Space Center 46 miles, altitude 35 miles. Ignition of the twin orbital maneuvering system engines on the tail of the orbiter, providing an additional boost toward ascent and heading off toward the International Space Station. Two minutes, 45 seconds into the flight.
Atlantis, 2-engine TOW.
Copy, 2-engine TOW.
Atlantis can reach Zaragoza in Spain in the event of a single engine failure. However, all 3 engines are continuing to perform as expected. Hydraulic systems in excellent shape, as are the fuel cells producing the electricity for the vehicle. 3 minutes, 20 seconds into the flight. Atlantis is 97 miles downrange at an altitude of 51 miles, traveling 6,000 miles per hour. Views from the external tank camera looking down the vehicle. Very quiet here in Mission Control as the flight control team continues to watch over all systems, everything continuing to go very smoothly with Atlantis' voyage to the International Space Station. 3 minutes, 50 seconds into the flight.
Atlantis, negative return.
Roger, negative return.
Atlantis can no longer return to the Kennedy Space Center in the event of an engine failure, but all 3 are continuing to perform well, as are the hydraulic systems and the electricity producing fuel cells. 4 minutes, 20 seconds into the flight. Atlantis is 175 miles downrange from the launch site at an altitude of 62 miles, now traveling 8,000 miles per hour.
All right, this has been an amazing sight. No matter how many times you see this kind of launch, the heart is beating a little bit more rapidly. It's obviously something that that all of us want to see, and it seems to be going rather smoothly right now, Miles O'Brien.
You know, Wolf, I got to tell you, every time this happens, it truly, I stop breathing for a little while because, frankly, being here and feeling the force, just the concussive force of, in particular, those solid rocket boosters as they're lit, as it kind of makes its way like a shock wave across the mangrove swamps to us and then hits you, like smacks you. It is bone-jarring, and to think when you feel that kind of power and you see the brightness coming off of that rocket, those rocket nozzles, as they make their way up, and to know that there are 7 souls strapped onto this, what amounts to a controlled explosion on their way to space. If you're not a little bit taken aback, you're not paying much attention. That's all I can say to that. It is a spectacular sight to watch this all unfold. Katie, what are your thoughts as you see it? You want to be there, I imagine.
You know, a long time ago, I figured out it wasn't my turn on this one, and just as you said, it is so powerful, it is so bright. You think you remember how loud it is and how bright it is, but it just can't, because it's just so much bigger than all of us, and to realize that there are people in there, they're going to space.
Zaragoza 104.
Miles and Katie, if you could explain to our viewers, there is an emergency landing procedure. We were talking about it earlier, one in Spain and one in France, but tell our viewers about that a little bit. But first, tell us about this rollover that seems to be happening right now.
Yeah, well, it looks like a rollover, but it's actually just the angle of the sun, and you're seeing sort of the shadow passing there, but they are doing a roll there.
Yeah, part of that is to maintain a good, healthy communication stream between the satellites or ground stations. They start off communicating to ground stations. As they get closer to space, they start communicating with satellites, and where the antennas are located has some of it to do with that. And they also need to prepare to jettison that external fuel tank, which heads on its way to the Indian Ocean, so they need to get set up for that as well. And so that's why the Earth is suddenly appearing below you, whereas it looked inverted a little before. You heard those calls coming up: 2-engine TAL, 2-engine TAL Zaragoza, single engine Zaragoza, single engine Zaragoza again, negative return. All of those have to do with the amount of speed and altitude and energy that the shuttle has. The more it gets, the more options you have for an emergency. The last call you heard, single engine Crest to Miko, or which I think they already did that, means even if they only had one engine, if they lost 2, they would still continue on until main engine cutoff and would be able to attain, I believe, some sort of orbit, correct?
Correct.
So basically, the higher they go, the faster they go, the more options they have should things go wrong. It begins with the possibility of them having to come back here. It moves into a transatlantic landing, perhaps. It goes to a degraded orbit, and then finally goes to situations where maybe they'd have one orbit around and landing, till finally perhaps even having enough of an orbit to maintain the mission. As they get higher, things get better for them.
And I just want to remind our viewers, Katie Coleman, yourself an astronaut, they're heading out to the International Space Station. How long is it going to take to get to the space station?
Well, we have a series of little burns that we do in order to catch up. And basically, we're always boosting up to their orbit. It actually takes about 3 days to do the final
main engine cutoff. You're going to watch that tank disappear. Matter of fact, if you could lose that banner right now, it'd be great. You could see that main engine go away. Lose the banner would be nice. And you'll see in just a second that whole separation there between the shuttle and the main engine. It's going to happen very shortly here.
There it is. Let's listen in.
Separation of the fuel tank has also been confirmed. The crew handheld photography setup will be underway shortly with a +X maneuver that's managed by the commander on board, Rick Sturckow. Atlantis following away. You can see the thruster jets firing as the orbiter is being maneuvered for the handheld photography.
Atlantis, Houston, we show a nominal MECO. OMS 1 is not required.